Welcome everyone to the launch of the fabric and structure of a net zero build project, which is part of the low carbon learning programme. This programme aims to support industry working towards achieving net zero in the built environment. The launch today aims to provide you with an understanding of what we will achieve over the next few months, why we're doing it and how you can get involved and upskill in the areas we will cover in the fabric and structure programme. This upskilling project is funded by Skills Development Scotland as part of the National Transition Training Fund, with an aim to support those working in industry to develop more green skills. The desire to upskill in low carbon construction has never been more relevant. Over the next few months, we'll be offering fully funded training in 4 specific areas. The first one is taking a fabric first approach and how it can help reduce consumption of energy and build towards greater energy efficiency. Carbon accounting and the processes which are now being used in construction projects. Mass timber solutions, looking at the whole life cycle analysis from forest floor to built environment and how it can help us with net zero, and also developing an understanding of the processes and practices of sustainable materials and solutions within construction. The training will consist of online immersive training and 2-day practical training courses at our Construction Scotland Innovation Centre Innovation Factory. All the training sessions are free. My name is Kay Keenan and I'm an Impact Manager at Construction Scotland Innovation Centre. And if you have any questions regarding this project, please get in touch. Today, we are going to hear from some experts who are leading the way around sustainability and net zero in the built environment. Sarah Edmonds is an architect and runs Search Studio. Dr. Sarah Graham is a Chartered Building Services Engineer who supports industry around carbon accounting solutions. And Tabitha Binding is from Timber Development UK, who works across academia and industry, supporting them around skills development. We'll also hear from Skills and Planning Manager in Construction at Skills Development Scotland, Elaine Ellis. SDF are funding this project and through the CSIC are leading the development of green skills across industry in Scotland. Before I hand over to Sarah, our first speaker, I just want to cover some housekeeping today. If you want to ask a question, please click on the question icon and post it there, and we will try to answer it in our question and answer slot. The webinar will be recorded and the link will be posted in social network channels after it's complete. Finally, there will also be some polls throughout the webinar which we're keen for you to participate in. And after the webinar, there will be an evaluation form. Please complete it as it helps us provide the best service that we possibly can. So first of all, here's a short video capturing our project, Fabric and Solutions of a Net Zero Build. Thanks everyone. Here is our first poll. On a scale of 1 to 5, what is your level of knowledge of net zero building, fabric and structure standards in the built environment? Okay. Thanks everyone. And now we're about to hear from our first speaker, Sarah Edmonds. Sarah is an architect who runs Studio Search with her husband in London. They have recently co-founded Home Energy Action Lab, a community retrofit social enterprise. She's a coordinator at the Architects Climate Action Network, co-founding a campaign called Households Declare. Working in the face of a climate emergency, the focus of her work is to drive systemic change in the built environment and wider communities through bottom-up grassroots projects and strategies. Welcome, Sarah.
Thanks, Kay. Yes, so my name is Sarah Edmonds, and I am really happy to be here today because I believe the work that Construction Scotland Innovation Centre are doing is really exciting. So I'm very happy to be part of this event this morning. Yeah, so as Kay mentioned, I'm an architect. I'm a coordinator at the Architects Climate Action Network, where I co-founded Households Declare campaign. I'm co-founder of a new domestic retrofit service called Home Energy Action Lab, or HEAL. And I also co-host Zero Ambitions podcast. My key areas of interest are domestic retrofit, campaigning and public awareness, and embodied carbon. So in the context of low carbon learning, I want to talk about the importance of a fabric first approach. But first, some context on where we are. So global warming led to 2020 and 2016 being tied as the hottest years on record, around 1.2 degrees Celsius hotter than the average temperature during the 19th century. Globally, we consume some 1 million barrels of oil a day, take 190,000 flights per day, and we lose a forest the size of a football pitch every second. The damage to ecosystems and extinction of species that cannot adapt is not a future ramification. It's happening now. Extreme weather events are increasingly common. This is the new normal. The construction industry has a significant role to play in the reduction of global emissions, as it is responsible for almost 40% of them. There has never been a more urgent time for action. The UK will not meet its legally binding targets of net zero by 2050 without near complete decarbonisation of the existing building stock. Many organisations are calling for a national retrofit strategy. We need an immense expansion of trades and professionals to meet this challenge. Construction Leadership Council has put that number at around 500,000 roles. So a fabric first approach, well, when we talk about fabric first, this really means demand reduction. It aims to minimise the energy consumption, such as maximising air tightness, increased levels of insulation, optimising solar gain through the consideration of opening locations and shading, optimising natural ventilation, and using the thermal mass of the building fabric. It's important to consider these passive measures before relying on energy-saving products or renewable technologies, which can be expensive and may or may not be used efficiently by occupants. So it's important to consider the fabric first. Retrofitting is also key to reducing our emissions. Increasing amounts of precious energy is wasted on heating and cooling the leaky buildings that constitute the vast majority of the UK housing stock. The only way the UK will achieve net zero balance is to match the amount of renewable energy generation that can be allocated to buildings against that which the buildings use. This will only be possible if we significantly reduce demand. But in the context of low carbon learning, I also want to talk about the importance of embodied carbon. Embodied carbon in construction accounts for 11% of global greenhouse emissions. Embodied carbon can be defined as greenhouse gas emissions associated with materials and construction processes through the whole life cycle of a building, including material extraction, product manufacturing, transport to site, construction and assembly on the site itself, refurbishment and replacement of components, deconstruction, waste processing, and the disposal of waste. In the 5 or so minutes I have, I won't get to go into deep detail of all the skills needed to meet these challenges. Construction Scotland Innovation Centre will do that through their training. But I can remind us all about the context. We need to move away from the linear destructive processes that we have seen wreak havoc across the globe and move towards the circular economy and regenerative processes. The best way I can describe this is to show an example of the donut as devised by the economist Kate Raworth. The donut consists of two concentric rings, a social foundation to ensure that no one is left falling short on life's essentials, and an ecological ceiling to ensure that humanity does not collectively overshoot the planetary boundaries that protect Earth's life-supporting systems. Between these two sets of boundaries lies the donut-shaped space that is both ecologically safe and socially just, a space in which humanity can thrive. This is a representation of the measured global donut. This is the UK donut. And this one is that of Ethiopia. It is clear that huge imbalances exist and that we have been damaging our ultimate home for too long, so we need to turn the tide. Consider when making all design decisions, all the processes involved. Does this building need to happen? And if it does, what is the most carbon neutral way that it can be built? Thanks.
Thanks, Sarah. It really helps to understand the wider issues and context around climate change and the work that you and other people are doing in the built environment at the moment, but also lets us see there's a lot of work that has to be done, and it has to be done right now. Thank you. There'll be an opportunity to ask Sarah some questions, so please post them in the chat box and we'll get to them after all the presentations. So now it's time for another poll question. So where within the built environment do you feel that net zero building, low carbon learning and upskilling is most required? Okay, so now we have Dr. Sarah Graham. Sarah has over 25 years experience in sustainable building design and operation and has a passion for building performance. A chartered building services engineer and a Doctor of Engineering, she currently has her own consultancy supporting industry towards transition towards greener solutions within the built environment. Welcome, Sarah.
Thank you. I'll switch my camera off if that's okay. Okay, so hi, Dr. Sarah Graham, founder of Creative Building Performance. Very happy also to be here today and be part of this exciting launch. Today I'm going to give a brief overview of carbon accounting and highlight why it's important for employers, managers and the workforce to have a good working knowledge of the subject.
Sorry, Sarah, we're not seeing your screen yet.
Oh, darn it. Okay, so if I try do that again.
Yep.
Stop sharing my webcam.
That's it this time.
Okay, good. Sorry, that was only an introductory slide then. Okay, so the module itself, the carbon accounting module, will aim to enable participants to develop a general overview of the key processes and practices behind the concept of carbon accounting, to develop an understanding of the barriers, challenges, risks, benefits, drivers and opportunities, to discover how the key processes of carbon accounting provide appropriate solutions to sustainability and net zero construction process, and to develop an understanding. Okay, I don't know what happened there, sorry. Can you still see the screen?
Yes, carry on, thank you.
Okay, sorry. Develop an improved understanding of the need to transition to carbon accounting standards in use. So I'm just going to sort of zip through all of that today, with the understanding that more detail would be included within the sort of developed module. So what is carbon accounting? The term essentially means calculating the footprint of a building, carbon footprint of a building structure, or indeed a business. Sometimes referred to as greenhouse gas accounting, the two terms are interchangeable, and it's mainly because carbon dioxide accounts for 76% of greenhouse gas emissions that the term carbon accounting is used, because if you tackle carbon dioxide sort of element, then it's the most prominent one. We use carbon or GHG accounting to quantify greenhouse gases produced directly and indirectly from a business, from a building, from an organisation, activities within a set of boundaries, and we'll examine what we mean by that a bit later. So I think Sarah covered off why it's important to get to grips with what carbon dioxide emissions we're actually producing. Construction, as shown here, is a large proportion in terms of energy consumption and carbon emissions, or greenhouse gas emissions, I should say. In 2020, CO2 emissions from the operation of buildings increased to their highest level at around 10 gigatons, or 28% of total global energy-related CO2 emissions. With the inclusion of emissions from construction, this share increased to 38% of the total global energy-related CO2 emissions. So within the current business model, as Sarah mentioned, construction, maintenance, modification and replacement of buildings and infrastructure is a major contributor and a significant producer of waste. Here, those emissions are indicated as direct emissions. So that's the material side of things, the embodied carbon. The emissions from power generation for electricity and commercial heat are represented here as indirect emissions. So within the module, we'll examine in detail how a fabric-first approach to construction and refurbishment can contribute to reducing those emissions, and Sarah highlighted some of the things to be considered in that approach. The carbon accounting enables us to take stock of the emissions and to look at effectively reducing them over time. So, firstly, we want to just look at the carbon accounting process itself. As one would imagine, there are various protocols in use which can be used effectively to measure and report carbon emissions at the organisational, city and country level. Some examples of these include the Global Reporting Initiative, or GRI, the Greenhouse Gas Protocol, which has been most widely used to date and is recognised by the UK government as an independent standard for reporting greenhouse gases. This protocol provides accounting and reporting standards, sector guidance, calculation tools, and training for businesses and government. And it establishes a comprehensive global standardised framework for measuring and managing emissions from private and public sector operations. Another example is ISO 14064 for greenhouse gas accounting and verification. The standard was published in 2006. And also provides government and industry with an integrated set of tools for programmes aimed at reducing greenhouse gas emissions, as well as for emissions trading. So these are only a few examples. There are more to choose from. For those of you who did tune into COP, you may be aware that efforts are being made globally to align the frameworks, because at the moment there are different boundaries, different timescales, different scopes within each of the different protocols, which makes it, more difficult for somebody trying to choose which one is going to best fit their purpose. Another term you'll hear very often in relation to carbon or greenhouse gas accounting is Scope 1, 2 and 3 emissions. And it's quite an involved topic, so I'll touch on it only briefly today. Many companies start with focusing on their Scope 1 and 2 emissions because that's what they're typically in control of. So Scope 1, as shown in the diagram, covers the company's facilities itself, offices, factories, depots, etc., and any vehicles owned by the company, as well as processes that the organisation might carry out, like manufacturing. Scope 2 covers indirect emissions that the company uses but is not responsible for the production of, e.g. purchased electricity, typically. And Scope 3, which is often the largest and the most challenging area, is everything else. And this will vary depending on the type of business. So Scope 3 for manufacturers can cover use of sold products. Scope 3 for a property management company might include landlord goods and services and occupant purchased energy, for example. This has been quite a kind of new thing that's come to the fore as well, as the idea of science-based targets. So these accompany carbon accounting as a way for companies to define emission reductions targets. So once you've established what your emissions are, how can you go about setting a target that's actually going to be meaningful? So unlike traditional potential-based targets, science-based targets follow a top-down approach, and they focus on emissions reductions required to meet the targets set out in the Paris Agreement, which is to limit global warming to 1.5 degrees. In addition, their net zero standard, which was launched in October 2021, gives companies a science-based framework for defining ambitious and effective climate targets, with a long-term goal of achieving net zero emissions. So you can set your own carbon budget, if you like, which aligns with the science-based targets within your own portfolio or your organisation. The driving force behind science-based targets is a joint initiative of the Carbon Disclosure Project, UNGC, WRI and WWF. It develops methods and criteria for effective corporate climate action and validates corporate targets as well. So it provides a clear science-based definition of net zero, and it's the world's first framework in the private sector for setting long-term, ambitious and science-based net zero targets. So the various frameworks mentioned all have guidance on the steps that need to be taken to complete the carbon accounting exercise, but typically they can be broken down as follows. First off, determine the boundary. This will normally be set out within the chosen framework, so choose one that you are comfortable fits your business processes well. Decide what's in scope and out of scope for your organisation and communicate that to stakeholders. Step 2 is to set up a data collection and management process. If your organisation doesn't collect currently any information on GHG emissions, new processes will need to be put in place. And it may be that there is a need to recruit new staff or retrain and allocate funding and duties to existing staff. Step 3 simply is to produce and submit the report, which is a short explanation for quite a lengthy exercise. And step 4, which is absolutely key, is third-party verification. All of the protocols will embrace that. It's essential to combat greenwashing. Much greater transparency around environmental performance and things like social value is required going forward so that investors can make informed decisions. And it's something, again, that is being ratified across the various measurement protocols. So some of the drivers then for corporate carbon accounting include mandatory, obviously, GHG reporting and directors' reports for companies over a certain size, investment due diligence, shareholder and stakeholder communication, and staff engagement. Also, tender requirements for business and government contracts. Accounting for greenhouse gas emissions is increasingly framed as a standard requirement for business. In 2021, the Carbon Disclosure Programme saw a record-breaking 13,000 companies sign up, which represents over 64% of global market capitalisation. So this is the trajectory that they've followed, and you can see the jump last year. 35% greater uptake than the previous year and over 141% more than when the Paris Agreement was signed in 2015. Carbon accounting and disclosure is good for business. It can differentiate companies large and small within very competitive markets. Some of the risks, I would say, we've already mentioned mandatory carbon reporting. The regulations are tightening up. In April 2019, streamlined energy and carbon reporting, or SECR, was expanded to include more medium-sized companies as opposed to large corporations. It's a government requirement to annually report and disclose energy and carbon information. For smaller companies, though, that fall out with that sort of bracket, the pressure comes from within the supply chain, from larger customers who are required to disclose performance. They will look favourably on suppliers who can assist them in that regard. So it's not to be ignored, I don't think, depending on size of organisation. I wanted to just come back to this point. So we kind of touched on the theme about this when we looked at science-based targets briefly, about how carbon accounting relates to net zero and sustainability in construction. I would point at UKGBC. They have produced some really useful and, dare I say, easy to understand guides to help construction companies get started. And again, there are efforts amongst various construction sector initiatives to coalesce how carbon accounting and reporting is carried out, but definitely look at what the UK GBC have been up to. Okay, so just to round off, carbon accounting can be daunting for firms. Where do I start? Do I really need to do it? There are lots of resources out there, and I've very much welcome the Fabric and Structure course, which I think will be extremely valuable in helping people to get started if you haven't already. And that's me. Thank you.
Many thanks for that, Sarah. That was really interesting, and it's very clear, you know, from your presentation that carbon accounting processes are going to play such an important central role in how we measure and manage emissions, and also how we meet these standards towards, you know, reaching net zero. So we've had some great insights so far on how we can take a fabric first approach, and looking at how we can low carbon solutions. So now what I want to do is I want to move on and look at mass timber and how the role that can play. So I want to introduce you to Tabitha Binding. Tabitha leads on education and engagement for Timber Development UK. With a background in forestry and milling, product development and certification, Tab now works with industry, academia and professionals, and infuse, encourage and educate, passing on her knowledge about all things timber. Thanks, Tab. Nice to see you.
Thanks, Kay. These webinars, I mean, they're great for disseminating knowledge, but they don't half make you nervous to make sure everything works okay. Right, here we go. Mass timber installation. So thank you so much for asking me to speak. I work for Timber Development UK, which is the merger of the Timber Trade Federation and TRADA. We know the world is warming, whichever way we look at it. I mean, Sarah spoke about it sort of earlier. We know it's being caused by man-made emissions, and we need to reduce all of those. You're going to come across time and time again about whole life carbon assessments, embodied carbon and operational carbon. And I'm not sure that you can see my...
Sorry, yeah, we can't see your screen at the moment. Shall we try
Why is
again?
it not showing? Screen sharing is paused.
Yeah, it's just blank.
So, okay, tell me what to do again.
I'll try just now, 1 second. Okay, it should be with you now.
Right, let's do something differently. Let's just move that down there and go. And let's make this big. Hopefully that will go back. And yeah, there you go. Screen. Does that work now?
Yes, I can see your screen now.
Wonderful.
Thank you.
Now, can I make it go forward? That's the question. Yes, there you go. Brilliant. Thank you, Kay. So as I was saying, whole life carbon assessments, you're going to see more and more about both embodied carbon and operational carbon. So here my screen on the left, whole life carbon assessments from Kieran Malik. This breaks it down into the modules that makes it very visually easy to understand, whether it's the product and construction to the site, so that's a cradle to gate, whether it's cradle to practical completion, which and then into use, or until it's including the end of life, which is cradle to grave, or actually, as we all need to be now, doing whole life carbon assessments. So right from module A all the way through to module D. And why is that important? Because we need to look at both the embodied carbon and the operational carbon. So the embodied here in red and the operational here in grey. And they are equally as important. And thank you to Akan and Sarah there. So as trees grow, they clean the air we breathe by absorbing the carbon dioxide from the atmosphere. The trees release that oxygen and incorporate the carbon into their twigs, their stems, their roots and leaves or needles and the surrounding soil. And as trees mature, they then die and they start to decay and slowly release that stored carbon back into the atmosphere. So these growing forests absorb, store and release carbon over an extended period of time. And this cycle is a closed loop. You can see here in the brown as it's, the trees, they grow from seed and they grow into a mature tree and eventually they will die. But we can improve that loop and the cycle by keeping them in production in the atmosphere, well, actually in the built environment for longer. So, and the biogenic carbon cycle fundamentally differs from the open one-way flow of fossil fuels, which cannot be replaced. So by using the trees that we grow from certified and managed forests and turning them into products that we then use in buildings, we lock up this carbon, which is basically good for everybody. So carbon is sequestered through the process of photosynthesis, whereby trees exploit sunlight to combine that atmospheric carbon dioxide with water to produce carbohydrates that become incorporated into the body of that tree. And oxygen is released back into the atmosphere. The amount of carbon sequestered depends on the species, but typically 1 ton of dry wood contains around 500 kilograms of carbon. And this ton of wood will absorb approximately 1.8 tons of carbon dioxide from the atmosphere. You'll then come up against a question about, do we have enough timber? And currently, yes. In Europe, the biomass in forest is increasing, and this is known as the annual increment. So if you can see here, we have the standing wood that's measured at the beginning of the year. We have the annual growth, because trees grow every year. We minus the annual felling and minus anything that's lost to fires or pest diseases. And that then is known as the annual increment. But this only obviously carries on growing provided we fell less than the forests are growing in that particular year. Our major construction material in the UK is softwood, and the main species we grow here is Sitka spruce. And we start with a seed. It is planted in forestry and managed, and then it is felled and milled and into planks or other products. And the yield that we get from any particular log can be between 50 to 70% of that log, depending on the shape and depending on the skills of the processor. The tree is divided up into several what the buyers buy. So we have the butt log, which it produces the most timber and is the most expensive. The middle log, which other different products are made from, and the top log, which will probably go for fencing, and all the branches and needles often now get chipped and go for biomass, and nothing is ever wasted. But Why are we talking about mass timber? Well, we've built with timber for thousands of years. And here on the left, you'll see this is Greenstead Church in Essex, which is thought to be over 900 years old, maybe more than 1,000. And on the right, there's the Red Lion in Hereford, which comes from the 14th century. But we are in 2022, and although some people love, small sort of cottages that were built from the timber that we grew then, and the designs were constrained by the length of the timber and the knots within the timber, but also how the processing and the milling, which was far more labour intensive in those times. But we now build incredible buildings that are tall and incorporate engineered or mass timber products. So this was completed in 2019 in Norway, and it was one of the tallest buildings at 85.4 meters tall. So that's 85 meters. It has 18 inhabitable stories, and it's manufactured from glulam and cross-laminated timber. But we don't just build tall, we also build big. Now, this is Dalston Lane in London. This stands at 33.8 meters tall at its highest point. It ranges from 5 to 8 stories. And by building in timber, which is light in comparison with concrete and steel, 35% more homes were able to be built on this site. And that included 589 less deliveries to the site compared with if the building had been built completely from concrete. And on the left, you will see it's completely brick clad, and you would never know that it had been built from mass timber. But we also build small. And this is a building which is all timber. It's built to the Passive House standard, so it's not only looking at the embodied carbon, it's looking at the operational carbon. It incorporates cross-laminated timber, it incorporates multi-ply, it includes cladding, timber cladding, and wood fibre insulation. But what's really impressive, I think, is after the owner and the designer had completed it and monitored it at every stage of the way, they've come back and said they used too much timber in this building. And I'll come back to why that is important. So timber products, we all start with the log, but it can be sawn, and that sawn timber can be glued or screwed or nailed or bolted or staked to make other products. Or it can be peeled into veneers, and those veneers can be stacked or glued together to make plywood or laminated veneer lumber. It can be chipped or flaked to make things like orientated strand board or chipboard. But here we are just going to be looking at mass timber. So one of what we would call, I'd called an engineered wood product as opposed to mass timber, is glue laminated timber, which consists of planks of wood basically glued together to form larger sections. Although normally 44 millimeters deep, the laminates, they can be made up of multiple species or multiple strength classes. So here you'll see it's all been glued together, and this image here is from Buckland timber, and this is Douglas fir. So here you're seeing it on the end, and you're seeing all growth rings. But glulam does not just have to be straight, it can be curved, which makes a huge difference, and not something you'd want to be doing on site. So this here is a building that you can't visit it, but it was on Grand Designs, and as I said, produced by Buckland Timber, and this is out of homegrown larch. I'll get these things to move along. So the one the mass timber you'll heard most of is cross-laminated timber. So it's essentially the same as glulam, except that the timber is built up in layers with the different layers laid perpendicular to each other. The resulting panel is a solid timber panel that has significant strength in both directions, and the ratio of these strengths can be adjusted by varying the thicknesses or number of layers in each direction. And a point to note is that cross-laminated timber always comes in odd numbers of layers, so 3, 5, 7, up to 9. I'm not sure that we've had 11. And those layers can differ in thickness, but they need to balance each other. So as we talk about more timber and for longing laster, say in fire, we're looking at increasing the outer lamellas to 40 mil, but that will be the top and the bottom. So it always needs to be evenly balanced. And we are a pioneer in the UK of building tall with cross-laminated timber. So the image here on the left and the right are from Murray Grove, which is Stadthouse, designed by Worthington and with cross-laminated timber from KLH. Now this is 9 stories, and with the bottom plinth story is concrete, with 8 stories of CLT above that. And from the photograph, no one passing that building would have any idea that it is a cross-laminated timber building. But you're very lucky, of those of you in Scotland, because you are now manufacturing it at the Construction Scotland Innovation Centre. And so you can see the building on the left going together, which is the Synergy building on the right, which I'm sure you will find out so much more about. Nail laminated timber. As the name suggests, it's made by stacking lumber or timber and nailing it together to form panels. This can be done on site or as prefabricated panels in a factory setting. It can be made with local timber or imported, and the nails could be timber, because we now have timber nails. It can be used in a single plane or staggered, having combed or fluted sections. So this is what you just saw before with Synergy, and this is like a fluted or combed section of nail laminated timber. But it doesn't need to be small at all. So here we have the Tissing Tanko Pearl Visitors Centre, which is from Structurecraft. But nail lam has been around for a long, long time. And finally, we have Dow Laminated Timber, and this is from Coedebredon in Mid Wales, and this is Williams Homes manufacturing it up in Bala. And it takes these stacked planks and it joins them together with wooden dowels. Now these wooden dowels are often beech, because beech has a high movement characteristic, and which is different to the spruce or the larch or the Douglas fir that it's pulling together. And this binds the timber together with no need for glues. But also we need to consider not only the structure, but the insulation. And the insulation is needed to slow the passage of heat. And this is where we will reduce now, not the red, the embodied energy, but the grey, the operational energy. From the image here, you can see we lose so much heat via our walls, via our roofs, and obviously via our windows. So we need to improve the U values of those elements. And you'll find out more and more about U values. You'll find that your walls will increase in thickness, but the U value is the lower the U value, the less the transfer of heat through those materials. But not all insulation is equal. So if you're using a natural material like timber, why would you not match it up with a natural fibre insulation? And a really good resource is from the Alliance for Sustainable Building Products. And you can see that we have insulation from wood fibre, from hemp, from straw, from cellulose, from wool, from cotton, and from flax. And there is loads of case studies out there. And the buildings that they have been used to insulate come in all shapes and sizes for multiple users. And natural fibre insulation, such as wood fibre, are very complex structures that have unusual interactions with water. And because of this, they have extremely useful thermal properties. They are good thermal insulators, but also heat moves through them very slowly, meaning that the internal environment takes a long time to be affected by the external environment. Now, this is important because we need to keep our homes cool in summer and warm in winter. And the effect of using wood fibre, we can encourage decrement delay, which helps passively regulate the internal environment and reduces the need for heating and cooling. One final example to land on is Maggie's Oldham, where they have used timber pretty much everywhere. The timber is clad with profiled tongue and grooved, which has been thermally modified. So this is a heat treatment to add durability to a timber. The boards have been secretly fixed to horizontal battens, which are shaped to allow rainwater to drain into the cavity. The battens are supported on the structure, which is cross-laminated timber, and the whole building has been wrapped in wood fibre insulation. And there is a case study online that you can go and do some more research in. So a fabulous building using all the best aspects of timber. So timber, multiple products, renewable, sustainable, can have multiple benefits for both us and our planet. But please respect its properties and use it wisely and well. Thank you, Kay.
Thanks, Tab. That was really, really interesting and takes you into a really in-depth look at it. And just to say to everyone, part of the practical training that will be taking place in this free course will involve people coming into our factory and using the vacuum press and seeing how CLT is made and looking at some of the structures that Tab had put on the screen there. So that will be a really integral part of this course. So thank you. So finally, I want to introduce you to Elaine Ellis, who is the Skills and Planning Manager at Skills Development Scotland for construction. Elaine's role at SDS is to work with the construction sector and related subsectors and to collaborate with industry, Scottish Government and other public agencies to implement skills investment and action plans for the sector and drive forward ambitions for the Climate Emergency Skills Action Plan. Welcome, Elaine.
Hi guys, it's great to be here today. I'm not going to share a presentation. I'm just going to do a sort of brief introduction to a little bit we do in SDS around the Climate Emergency Skills Action Plan, and just mainly here today just to thank Innovation Centre for pulling this together and to just say how delighted we are to be involved within this project. I think the fabric and structure of Net Zero will be an excellent series, and we sort of look forward to moving forward, and certainly from the introductions from Tabitha, Sarah and Sarah, it looks like it's going to be an absolute wonderful project. I think from our side, in my day job as construction sector manager, which I also have part of a day job as forestry, so it's been really interesting to hear that side as well. Construction is absolutely at the heart of Net Zero, and as we move forward, when we start to look at how we're going to improve the buildings that we currently have, when we redesign our built environment to move towards net zero and to move towards a net zero economy, and as we really think about how we build and we really think about how as a construction industry do we build better, It's going to be such a positive space to be within construction, and it's really fantastic that as a sector it's going to be at the forefront of the transition to net zero. And I think it's an incredibly interesting and exciting time in terms of construction. Within SDS, I sit within a team, and it's sort of named Team Climate Emergency, which is genuinely within our sort of job role team title. And we're part of and one of the areas that we worked on, and it's something Kay mentioned right at the start, is we created the Climate Emergency Skills Action Plan way back in December 2020. And that action plan looks at a strategic overview of the work that needs to be done to start to transform the skills base so that we have the skills needed to meet net zero. Now, it's an absolute massive challenge, and it's definitely going to be one of the biggest challenges of our time. And certainly within that, we focus on 5 sectors, and one of those 5 sectors, not surprisingly, is construction. And number-wise, we've done some work around the evidence base, and it looks like we're certainly looking at around about 85,000 individuals within constructions whose jobs will be there. The jobs need to change in order to meet the needs of net zero. I think in terms of upskilling, part of the research and some of the evidence that we gathered with the action plan, and I'm not going to discuss in detail the research, but there's 2 really basic things that are standing out for me. One of the things is we spoke about the need for cultural change, and certainly within the industry it is about new culture change, it's about whole new ways of working. The other thing that really stands out was wording around the need to transform at pace, and I think we're absolutely at the start of that journey. I think it's a very, very exciting time. I think in terms of upskilling and preparing for upskilling, what's really standing out to me is this isn't the type of upskilling where it's a one and done, where you go along, you learn a few new skills and off you go back and can implement them fairly straightforward. What we're now starting to talk about is a type of upskilling where we're absolutely driving change right through the industry, and change right down, you know, the title says it all, changes that impact right from the materials that we'll be using and how we'll be putting things together, right through to the techniques that we're using, right through to how we're disposing when we get to demolition at the other side. And if we actually choose demolition, you know, going very back to the first speech from Sarah, that, you know, will we actually choose to reuse the buildings? There's going to be a huge culture change. It will impact across every single job. I thought it was interesting, the poll at the start where it asked the different areas that needed, and I think it was quite evenly divided amongst many of the areas. Slightly smaller one for building standards, but again, I'm pretty sure that if you worked in the building standards department and the people that are connected there, I think that's more about volume of people connected. It is going to impact on absolutely everyone. I think the Innovation Centre have a lot of great work here. They have their low carbon learning project, and I would definitely encourage everybody in the call to look at the work in the Innovation Centre and join in and connect with the other pieces of work. I think over the coming months, certainly within the Climate Emergency Skills Action Plan, we have information on SDS website around that. There will be further training, further funding, further opportunities that will come out in this space. But I think in general, it is about taking that pause, and that is maybe one bit of encouragement from today. It is just to take that pause and really think about how we're going to use this. How are we going to start changing the industry, making it norm? I'm conscious on the call there'll be a wide range of people from different job roles that will have sort of different levels of influence, but how do you use the influence within your own roles? How do you then start to make, you know, and build net zero into construction industry and just make working that way the norm, and really making it the sort of first port of call, not about cost is important, but really making net zero becoming the first port of call and how we do things. And I think certainly within our role in terms of the Climate Emergency Skills Action Plan, it's all about collaboration, and we're working increasingly cross-agency, with employers, working cross-industry. It's not about any one organisation leading or doing. And I certainly, again, with this side, would encourage you to look at where you can collaborate and where you can work together. But again, excellent speeches today. Thank you to everybody that spoke, and we are absolutely delighted to be able to support it. Thank you very much, guys.
Thanks, Elaine. And as Elaine said, you know, the low carbon learning programme, fabric construction is part of that wider programme. So although we're launching this today, they'll follow 4 modules that people can take online, and then there'll be practical sessions that people can come along to the factory and they can learn more about mass timber solutions and how to make CLT. You can also look at you know, sustainable materials, you know, and we have the thermal bonding line, and we can show people how it's done and what materials can be used. but we also have another wider programme around retrofit, which people can go on and engage, and it's fully funded. This training is free to those who work in the built environment, and it's really, we keep using this word transition, and one of the things that we talk about sometimes is a just transition, and we have to make sure people aren't left behind. And one of the ways we can make sure people aren't left behind is by having programmes like this and having collaboration with SDS, and that people like Sarah and Tab around this idea of we're all working towards the same thing, and we all have to make sure that everyone in the industry is actually involved in it, and they understand. We know there are challenges, but they understand there are ways in which we can get there. So, as I said, each month there will be a webinar on the 4 topics. The first one will be the Fabric First module, then it will be the mass timber solution, followed by the carbon accounting, and then finally the sustainable materials and insulation one. The sessions will introduce you to the topic, as well as run you through the online learning module, and then there'll be practical training sessions at the Innovation Centre. So please look and list today. Let us know if you're interested in sign up, and then we'll get back to you with the details. So let's look now at some of the questions that we have. So there's been lots of questions that have come in. And so one of the first questions that we have, and this one is to you, Tab, and it says, this is from someone asking, it said that in your presentation about using too much timber in the building. So could you maybe explain what that meant?
So it's picking the appropriate structural product for that particular building. So cross-laminated timber has multiple benefits, including sort of like strengths and large spans. So you wouldn't necessarily use it as in the bungalow I shared, the large corner, because you will overuse a certain amount of timber in that building. And we only have a finite amount. So it's that's why I was saying about the architect and the owner. They would have changed their structure to incorporate less timber. They'd have gone over to an I-joist system, faced it with 3-ply, which looks like a very thin cross-laminated timber, and then used a structural racking board on the outside. So they'd still have all these same effects that they were looking for, but it would have used less material in that building. So that's what I'm talking about. The amount of timber in that building is quite important. We need more timber in more buildings, not more timber in one particular building. Does that?
Yeah, I think that's a really good explanation, Tab. I think this one is for Sarah, possibly, and this is from Kirsty, who's asking, is there particular things to consider for fabric and retrofit when we're looking at Scotland's housing stock, particularly around tenements? So that's, I suppose, looking at the buildings, that a lot of social housing buildings, which there have been projects in particular areas. I'm thinking about Nidri Road in Glasgow and over in Edinburgh as well, where they have taken a retrofit of a tenement style building. So is there a particular consideration that they should be looking at when they're taking on these projects?
Yeah, I think the consideration is probably the same across all retrofits. Like, the key is risk management. And what we mean by risk, there's sort of 2 ways of looking at that. So there's the risk management of occupant expectation and how well you communicate what your proposals hope to achieve and how you're going to measure that on the other side. And the other is about the actual technical risk management. So, and it's the same in almost all retrofits. The same issues need to be considered, which are really moisture risk. So, retrofit, on the face of it, people can feel a little bit like, well, we'll insulate it better, and then once we've done that, job's done. And often that's not really the case. You've got to really, actually, I was really enjoying what Elaine was saying towards the end about taking a pause, and this is true across the industry in this moment of lower carbon construction and retrofit, is that we're very much at the forefront of this sea change that is coming, and we need to make sure that we understand what we're doing properly. So when it comes to any retrofit, absolutely key point in the game is that you have a whole building plan so that you can manage that risk, so that you can manage the expectation, and you must include the occupant as part of that. Anika Kelly in Carbon Co-op in Manchester put it really well. She talks about the occupants, no matter what the tenure, as resident clients, and it's important that you view that. If you don't have the buy-in and the understanding of occupants, then your retrofit won't work as well as it could do. So having that engagement is key, and then understanding the steps that you set out in place by understanding that building first. And nobody likes to spend the time at the beginning getting to know the buildings, because it doesn't look like you're doing anything, but actually that is the absolute key moment of like really understanding how does the building work as a connected number of systems. And again, harping on about it, but the occupant is part of that system, the ventilation is part of that system, how moisture moves through that building is part of that system. And there is no point in doing anything to a building unless it is retrofit ready. So you've got to make sure that any of the repairs are done first, and then you apply what your retrofits will be. But specifically in tenements, you know, you've got a different structural makeup there. You're talking about like significant chunks of stone building, and so what you might apply to that would be different to what we might be applying to, say, solid brick buildings or even cavity wall brick buildings. But yeah, Tab, you might know a little bit more about that, having done your own deep retrofit of your own old Welsh home. I don't know if you have anything to add to that as well.
I think it's incredibly important to pick the right materials that go together. And I know, Sarah, you know my home well. I gave a display of it, but mine is brick and lime. So I used cork internal insulation and wood fibre and sheep's wool, and then a wood fibre sarking board, because that suited that things. But retrofit is so much more complex than a new build. And there's so many skills, and it's so exciting. I get all excited about it. Sorry. It's a great industry to come into. Please come and join us.
I do too. I think it's a really important, it's the most creative opportunity. So if you're listening as an architect and thinking, oh yeah, but it's like fiddling around with old buildings, it's hugely opportune. Like the opportunity there is massive for creativity and for new use of new materials and low carbon technologies and natural materials as well. There's a huge opportunity there to really like expand that. And there's only really positive things, positive outcomes in that field, in that sphere. And yeah, using more natural materials like wood fibre insulation, that's a beautiful material to work with, but also the what it gives you back, the benefits that it gives back. I've just specified it in a really kind of bog standard project, but the occupants love it. It's where we've used the wood fibre insulation, the acoustics are better, the sort of the temperature being maintained is so much better. It's a steady state, and they really love it. And I think it is again having that long-term view, because yes, in the first instance it's going to be a bit more expensive, but actually when you're talking about single family homes, the economies of scale aren't there to make that big a difference about using wood fibre over using like PIR insulation. So it really has a lot of that, and Tab shared a lot of really good resources. So Back to Earth have a great tool on their website for architects. It's like a whole piece of free education and module learning about wood fibre insulation. So there's lots of resource out there to like find additional support in using the right materials, but risk management and a whole building plan, you got to have those two things.
Yeah, thanks, Sarah. Also, Sarah, I mean, we're talking very much around retrofit and insulation, but you know, carbon accounting is equally important, and we know that there's a lot of new tools that are out right now, and we're looking at processes anywhere. So if someone was watching this today and they're maybe just starting their career in the built environment from the design stage, or they're working in their own business as an SME, what's the first piece of advice that you would give them around carbon accounting? Oh, you're muted, Nick. Yeah. Oh, still no.
Unmute your mic.
Sorry.
Like that. Yeah.
That was just a synopsis of that was start small, you know, manageable chunks, really especially if you're trying to bring other stakeholders along with you, because it's just getting into the habit of collecting the data, as I talked about before. You need the data to produce the report, and it needs to stack up. So that can be quite a time-consuming exercise to get the ball rolling. But once people in the organisation are sort of up to speed with it, then it can, you know, it becomes less of a challenge then, just part of the process. Yeah,
and that's some of the
say,
things that we'll cover in the module, isn't it? You'll cover that. I know that you're developing the module for carbon accounting, and we'll bring people into the innovation centre, and we can do scenarios with them and show them how that's done.
Yes, absolutely. Yeah, what's realistic for different types of entity, as I said before, if it's a manufacturer versus a construction company versus a building owner, you know, because yeah, absolutely, we will cover that.
So another question now, and this is a question that we hear quite a lot when around wood and timber, and it's from Neil, and he's saying, how do you address the fire and water damage risks and convince insurers to engage and offer cover for timber buildings? So Tab, I don't know if that's one that you want to answer.
Yeah, well, interesting. So people normally get really concerned about, you know, sort of fire, which obviously you need a fire strategy, but actually bringing up and actually understanding you do need a moisture strategy is a fantastic first step. So it's about keeping it dry during construction, or if it has got wet in construction, then allowing it to dry either naturally or with you know, other means, to below 20% moisture content, because that is the decay threshold. If it's held above 20% for an extended period of time, it will break down. And then your water mitigation strategy while you're in use. You know, can you check on it? Where have you put? And then to me, and we should be all building to passive house standards, which means a reduction in energy, which means a reduction in water use and that heated water use. So stack your bathrooms and kitchen either on top of each other or next to each other. Minimize where your water comes into that building, so that's the in-use potable water, and make sure that you can check on it. But again, it's just like building maintenance. Ideally, don't put a flat roof on it, put a sloping roof on it. If you can, you know, architects I know seem to love internal gutters, which just cause problems for everybody apart from the architect. You know, really consider where that rainwater is going to go. It rains in this country and it's going to rain more and heavier and for extended periods. So to start with, shed the water. Keep your building off the ground. We call it putting a hat on and boots on it. So it needs to be a minimum of 150 or 200 mil from that timber, unless it's been designed, like say something like a coir, to actually sit, you know, in water. And it's just like good design to start with, backed up, you know, by you know, showing everybody that that's what you've done, and then just keeping on top of your maintenance and keeping up on your inspection like you would with everything else. And as we're showing, you know, buildings have lasted thousands of years built in timber. Does that?
Yeah, definitely. And it's, you know, there's another question quite similar, which is asking, you know, how do we get leading designers to move away from using steel and concrete? And, you know, what's happening right now? What ambitions, you know, COP was held in Glasgow, and what ambitions are there right now for us to have net zero by 2030, which is the Scottish target, you know, of the interim target that we have in Scotland. So I suppose, I don't know, does anyone want to answer that about what's happening at the moment around, you know, different projects?
I can just speak a little bit to it. Sort of touches on another question that I think somebody mentioned around getting developers on side, and I think this comes back to kind of just building on what Sarah said about small steps, but making it more regular, like common parlance. Really, it comes down to education and awareness. And if that's, I sort of feel like that I repeat myself ad nauseum about the context. You can't really continue in the status quo, because that's only going one way, and that's bad. You've got to understand the context and then see that actually the opportunities that are afforded by changing the ways that we're working, there's great opportunity in that. And then ultimately, I think that if you don't join the movement now, it's going to cost you in the long run. You need to be moving now when when we, you know, the pressure is there, the proof's there, the evidence is there, and also on top of that, the support is there. The industry is moving quite a lot towards these lower carbon approaches, this lower carbon technologies, and you just can't substitute by it if you're not part of it. I really do think so. Like, you know, it's scary at first. It's a bit like, you know, oh well, we've done it this way and we're just about keeping our business running, so we don't really have time. And I understand that SMEs particularly struggle because they don't have the time and the resource to like fully retrain. And this is where things like, the reason that I'm so thrilled to be part of this conversation is because what organisations such as Construction Scotland Innovation are doing is really important, and offering that sort of support and showing it. Actually, really, I'm so excited about the apprentice approach to stuff as well, because if I had my time again, I wouldn't be going studying architecture. I'd be right up there doing all of your apprenticeship courses, doing this like hybrid virtuality learning stuff. Is just like amazing. Virtuality, is that a word? So I think that's really exciting what you're doing. So it's really about education, and it's really about pointing towards pieces of research that organisations like LETI, that ACAN, that all sorts of you know, cross-industry coalition groups are doing, and it's talking about it all the time. It's just asking simple questions like, did you know, like, the amount of carbon in that is that, and the amount of carbon in this is that, and what that can do to, you know, and the impacts of it. So it's like making that part of everyday language in your organisation and in your design teams.
Yeah,
and I suppose it's knowing that, yeah, absolutely, yeah.
Yeah, so it is changing, and it is, and as Sarah said, it's often breaking down the silos between professions and between institutions. I mean, we all want to cleave to our own group, and maybe we've got so far up our group, and you know, and we really don't. But this time we're moving beyond that, and that's where I've been really pleased to see that TRADA and the Timber Trade Federation have merged, and then we're working across, you know, with ACAN, and then we're obviously working into REBA and into iStruct and into CIAT, and working obviously with Construction Scotland Innovation Centre and into Edinburgh Napier, and there's a new sort of college come university being set up down in Hereford, so NMITE, the new Model Institute for Technology and Engineering, and all these courses and sort of like bite-sized learning are for not just our future professionals, but they're also for our current professionals. And basically we're all learning. This is new territory for all of us, and the more that we can work together and collaborate and get outside slightly our comfort zone and work interdisciplinary, I don't know, the more fun it becomes. But actually it is I suppose just partly leading by example, but also just knowing we have to do it.
If I just build one comment on that as well, is that being comfortable to share learnings from your mistakes. You know, nobody knows exactly what they're doing. Nobody knows that we don't have masses of case studies like compared to what we have from before. Got to be comfortable in sharing those, because it is through making those mistakes and sharing those outcomes that we can improve upon it. And we've not been very good at that as an industry historically, but there really isn't time for that. No one's going to stand there and just point at your mistake and give you grief about that. It'll be like, okay, great, you tried that, so we don't have to try that again. Now we can try the next bit. And you work and you collaborate. Like everybody on this call has said, collaboration is absolutely key. Kind of have to get out of our own way and sort of view each other as a great big collaborative team, all moving for the same outcome and end goal.
Yeah, definitely. Anyone else before we wrap up for the day? So I'd just like to say thank you to all of you for, you know, sharing your knowledge and expertise today, and also, you know, giving an overview of the programme. So can I just say to everyone that's enrolled today, please ensure that you register your interest on the link that Danielle will post in the chat. There's also on the chat, you can download a PDF which will give you all the details of the 4 modules that will be developed. And then, as we said, there'll be practical sessions and online immersive learning as well. So we'll contact you directly with the options of the courses that are available. But what I do have to say, because of the previous courses that we've run, please be aware that it's snapped up very, very quickly. So if this is something that you're interested in doing, please register straight away. So before we finish, I think we have one final poll before we finish today. So what delivery mode of net zero building, low carbon learning, would be of most value to you or your business? Would it be online, face-to-face, blended learning, or a combination of all of the above? Okay. Yeah. It's good to see, because this programme is a combination of all of the above, so it's really positive to see that. So thank you everyone for joining this morning. Thank you to Sarah, Dr. Sarah Graham, Tab and Elaine for supporting the Fabric and Structure project. We hope this project will have the desired impact that is to work towards a net zero carbon built environment. Also, thanks to Danielle for doing all the all the tech and IT behind the scenes. It's always difficult with these events. It's been really well done. So thank you everyone, and as we said, please go into the chat, register your interest, and all the programme will be following throughout the month of May. Thank you. Thanks everyone. Bye now.